Hi everyone. Hope you're having a good day. This morning, I took like 1 hour or 40 minutes to finish the one problem of today's contest, and since I have a little more time, I hope I can finish this two city scheduling thing, which is also in today's context, and yeah, and then I go to sleep. So. Okay, so let's read the problems first. So there are two N people in a company is planning to interview. The costs are, yeah. So for each cost there will be a array. The first one is cost to A. The second one is cost to B, and so we return the minimum cost, so that exactly N people arrive in each city. So let's take an example. Example here is for uh, two-dimensional array. So this means that if the first people it costs 10 to go to A, and 20 go to B, and the second one is cost 30 to A and 200 to B, and the third one 400 to A, 50 to B, and last one is 30 to A, 20 to B. So the output is 110. So for A, the minimum is 10 and 30, like this 30. And for B is 20, 50, and 20. And this is already used, so I think we should put this to A and this to B. So we got 40 plus 70, and it got 110. So how can we solve this? I remember the commitment here. So I've done a little thinking about this problem. Is that let's say if we had if we sort them. Mm-hmm. Uh, I think the first thought is that we maybe just split into two groups. We should just put it randomly. So the first n. So the first is okay. So a cost. So okay. So this is go to A, 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 and B, 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 B. And because they have different costs, so we need to sort them. I mean, sort the A by the cost, because after we setting them to two groups, we'll just switch them. So I sort them, so that A1 sort. I just say sort, and so that this is max more cost to A. How can I make it? I mean, sort. Yeah, just to sort them. Sort them with highest cost. Now we switch. Okay, like it got A1, A2, A3, A4, B1, B2, B3, B4, and now switch A1 and the B1. I mean, if A1 if it is worthy. If they switch, it will cost more, cost less, and then we just switch it. And then we have to sort them again. Why we choose this A, B? Because this means if we choose if we can choose for B, it will, if we A rather than A, we will get more cost than A. But it doesn't mean that if you go to A for A, it doesn't mean that they will gain a little less, right? They will generate net less cost to B. So this solution, I think it doesn't gonna work. Let's take a closer look at this example. What would it be if we just already done with the final choice, like A1, A2, A3, A4? These four people go to A, and these people go to B. It means that if we change any of them, it will generally cost more, not less. So if we change A1 with A with any B, the total cost doesn't go down. In this case, this is the minimum. So what's the, let's say if we get example, if we got something like this, it actually doesn't count because we can change these two with A down and B down. Or we can change these two with A down and B plus. And A down and B down. So definitely we're gonna change these two. So we change it. And then, can we change more? So if I want to change this one, we will find the A1. So we will minus 300. This will minus how much? But this is interesting. How can I decide which numbers to switch? If I have to compare all of them, I've got an idea. Just as what we do just before, we just pick so okay, it's just decided by A1, A2, and AN. B1, B2, Bn. And now for each B, check the max cost decrease. For each A, this is cost as O n square. Okay, I'll say O n n. If save cost, switch them, and we don't need to change them back. And okay, so that's where we're done. So what we need is for let I equals n plus equals n. I is more than 2 times n. I plus plus. Let j equals 0. Okay, that's 4. Okay, let max saving equals 0. Let max saving index 0. Let's for let j equals 0. J is more than n. J plus plus. Okay. If costs j, so if we switch them, if the cost of cost I minus it, this is what it costs. Cost change, so it should be okay. So I 0 minus cost j 0. This is the change for place to A, and plus cost plus cost j1 minus cost I1. If this sum is bigger than max saving, cost saving equals this is the difference, right? So if saving is bigger than max saving, update it. Max saving equals saving. The index is 0, 0. Okay, max saving 0 equals j. Max 0, 0 equals I. And we should switch them. And just after we finish them, switch if there is saving. If max saving is bigger than 0, and we switch it. So cost cost temp equals costs max saving 0, max saving 0 equals costs max saving 1, and the costs max saving 1 is equals temp. Now we sum it up. Okay, after we've done all this, now sum them up. Call let result equals 0 for let I equals 0, I smaller than n, I plus plus result plus equals costs I 0 for let I equals n plus 1, n is 2 times n, is 1, return result. I think it should be work. It is good. It's very pretty straightforward, but I still make mistakes. Oh shit! A syntax error. Like J. Oh shit. N is not defined. Ah, sorry. Costs. Cost n equals. Oh shit. There's so many typos. What? There's no consts, man. So now we output what? Console log like saving. I say I is 2, the max saving is 500. So max saving index J and I. Saving. Okay, max saving is big, so we switch it. Cost max saving 0 is 1 temp. Okay, and then we go to the third one. Okay, so we actually can save 520 minus 30. Okay. Okay, it actually it is the good one. So we switch it. Why we're switching it? Two. I made a mistake of saving. Saving means how much you can save. Ah, so sorry. Should you be J minus I? Because it's bigger than it, so you should save it. And so for this, the same thing is I minus J. Ah, shit. I think we're getting it right, though I'm not. Though our complexity is O in a square, it's maybe not that good. What? Maybe they're not any people working on it, right? Because no one is doing it in JavaScript. Could we do better? Um, I don't think. I'm not sure, but it's very tricky. Every time we compare to candidate, there are two factors we need to consider. One is the cost to A, and one is cost to B. Even we even we sort it with log n, and we cannot say we can skip any comparison, right? Let me say if B1 switches for A1, and for B2 we have to switch them all again, because there's no even if A may be sorted, but B, the cost for B isn't. So I think this is the anyway, I'll take a look at the discussion. Wow, it says 1 millisecond. O-log and sort. Wow, this is seems cool. How much the money we can save if we find out A to versus B to minimize the total cost? We should find a person with the maximum saving to A and with the minimum saving to B. For example, this one, he can save 70, 73, and so obviously first person should fly to A. And last to B. We sort your array by difference between constant and A, B, and then we fly first n people to A, and the rest to B. Wow, that's simple? Man, this is really simple. So the assumption is that, so if one is go to A, we'll save some money, and go to B, we'll save the minimum save. What? So there's no need to switch. So we actually let them all go to B, and then we pick up the people. Yeah. I made a mistake. So generally we can say we are we first all go to A, and then find the top n people who can save the most. Okay, the before this we are running in 60 milliseconds, Okay, I remove this and okay. So all go to A, and we find the people go to when chosen to go to B. So for cost, we sort it A, B. So what the saving, it can save to when from go to A to go to B. So the cost would be return A 0. This is the cost go to A minus A 1. This is the saving. So we should sort it by biggest number. So we should return B 0 minus B1. This is the saving for B, and minus this one, and then we just sum them up. Let sum equals 0 for let I equals 0, I is more than 2 times n I plus plus, sum plus equals I smaller than n. If this is cos I 0, if not cos I 1. Return sum. Wrong code. What is the n? Sorry. Cost n equals cost length minus 2. Okay, we cost again. Again, this 600. Let's see. I forgot the sword. Maybe I made a mistake with the sword. So this means that the people from A who go to B, this is what they can save. If it is smaller, then B will be put behind it. I forgot. A 2 4 sort A B A minus B. This is the ascending order, right? Yeah, so B minus A. Okay, B minus A. So the top should be sorry. So the top one should go to B. So we just let them just keep them there. Okay, then we are getting the right answer. Cool. 60 doesn't change. This is O log n, and that one actually it got a smaller memory, but the runtime is same. For this one, actually, we're doing the I see. Actually, we're doing the same because we are actually doing the switching without sorting. But this is strictly n square, so this sort thing is better. Though it is not reflected on the test result. Okay, so this is for today. Okay, from tomorrow maybe we can take a look at the other questions, the problems, like this one, medium thing, maximum sum of two non-overlapping subarrays. So let's have a brief look at the problem and go to sleep. Given an array of non-negative integers returns the maximum sum of elements in two non-overlapping subarrays, which have lengths L and M. For clarification, the L length subarray could occur before or after the M. Formally return the largest V, for which, so the L and J to M, and either what? Seem difficult to understand. So this is the sum of under L, and this is sum under M, and either I is J is what? Non-negative? It's really difficult to understand. So largest V for this is I 0 to I plus L minus 1. So this is the nth F L and M. This is the L. I see. So you will be given an array and L and M, and you should define these two subarrays and sum it up. So the first one is give you one number, two number, so we can pick the largest 9 and 6 4 6 5 got largest, and 3 2, so we got this one is biggest, and this one is the biggest, and then we sum it up. Okay, that's for today. Let's stay tuned for this problem tomorrow. Have a good night. Bye bye.